Thank you. Everything good? This is so weird. I can't tell anything that's going on here. That said, I'm sure I'll get used to it very quickly. As stated, my name is Tom Weeks. I'm the COO of Point One Navigation. We're based out of San Francisco. We're a global provider of software and services that are used to provide precise location. When I say precise location, it's 1 to 3 to 5 centimeters for devices to know where they are in the world. Just to get going, how many of you are, I'd say, unfamiliar or lightly familiar with GNSS, RTK type technologies? Okay, so most of you are familiar. If you're not or you want a refresher, right down this aisle you'll see our booth. There's an autonomous race car in the booth. It's really hard to miss. And you can have a no-obligation conversation with anybody in that booth, and they'll be happy to talk to you about kind of the underpinnings of what the GNSS and RTK systems are about. But most of you sound like you are familiar with it. What I'm going to focus on here in this presentation, it's not going to be a technical deep dive, so hopefully you won't be too disappointed. You can get that in our booth as well. What I want to focus on are the 3 key innovations that are happening on the location platform side where we play, that are really enabling OEMs and software platforms to build complete and efficient solutions for your customers to provide that really precise location. Oh, I need a clicker. Here we go. I'm going to assume right is forward. Yes. So starting off with one important thing that most of you already know is everything starts in this world with GNSS. And the reason I say it's an amazing time for GNSS is because things are getting incredibly cheap and incredibly powerful. Where 5 or 10 years ago, the expense on both the hardware side and the services side meant that only high-end products could take advantage of this. Nowadays, again, as most of you know, we have very, very cost-sensitive consumer products, including things like dog collars and lawnmowers, and cost-sensitive business applications like asset tracking of containers, and even cows, believe it or not. If you aren't aware of that, there's a lot of cow tracking going on. But the cost of these things has come down so much that it's now ubiquitous. And of course, the signals are free. The challenge has always been, historically, that obtaining this high accuracy with the services and the software has been a lot more difficult. And 3 big reasons for that, and obviously the opposite of this is what we focus on, is 1, the fragmented corrections environment, meaning country to country, state to state, you will find various providers, various levels of coverage, various quality of coverage, and piecing that together as an OEM is exceedingly difficult. 2, I would suggest you actually want an end-to-end solution. You don't want to piece together solutions and say, hey, when I have an open sky and I can actually see the satellites, I'm going to use this solution, and then I'm going to write some code and put in an IMU in my device so that when I get occluded, if I'm under a tree, if I'm going through a tunnel, if I'm going under a bridge, now I'm piecing together my own solutions. And so platforms like Point One are pulling together the entire platform so that you get the delivery of the solutions regardless of the environment. And then thirdly, and this one as an old software, and old, of course, software person is most exciting for me, frankly, is around the integration element. It's been really, really hard as modern robotics people to integrate into these solutions. And again, from a platform standpoint, so I'm afraid this is going to go again, we're really changing the paradigm on these 3 dimensions. I'll spend a minute or 2 on each one of these a bit later, but solving this fragmented network problem, solving the complete solution problem, and the integration and creating literally it is a wildly efficient integration paradigm is what really changes the game for folks like you. And what's in net effect? I mean, this is what we're all really looking at. It's not that we want cool technology and stuff that's easy. We want it to be easy for the customers. We want their experience to be seamless. We want them to turn things on and have them just work. And that's, at the end of the day, what we are enabling. Okay, so how are we changing the paradigm on those 3 dimensions? So first part of this is the actual corrections network itself. And on the basis, for those unfamiliar, the basis for correcting GNSS, again, it starts with GNSS, it starts with your device receiving a GNSS signal, and it's people like us providing you data and information that helps to essentially correct that signal. And where all this starts and ends is in the network. And the two aspects of that are the density of that network and the ownership of that network. So let me start with the density first. So there is no way for a math problem to solve the challenge of your device, a rover, being, say, 100 kilometers from two different stations. You can have the smartest mathematicians in the world building math models to try to make sure that thing knows where it is, and you cannot solve that problem efficiently. You're just too far away. So regardless of the delivery mechanism, and by that I mean, again, for those who are more familiar, single baseline delivery where you're getting corrections from a single station, or a virtual reference station approach where the solution will create a station that's closer than those 200-kilometer stations. Both of those are going to be highly challenged because the data they're getting are from stations that are far away. So it starts and ends with density. And so looking for density, it used to be, actually not that long ago, where it's like 100 kilometers is fine. It's not fine. Right? You're going to be in float stage frequently. You're not going to get the centimeter, 3 centimeter accuracy you need. And we're now coming down to understand that even with the best receivers, 50 kilometers is starting to become the edge. And folks like us are deploying networks at 30 to 40 kilometers across wide swaths of landmass. So it's not just concentrated in cities. So that's the first critical thing I encourage you to actually look for, is to make sure that you've got the density that you need for the coverage that you need. The second part of this is the wholly owned aspect. So deploying these networks is hard. It's thousands, and I should have brought a station with me. It's thousands and thousands of stations that have to be sites found, installed, monitored. And the easy way to do that is to have somebody ingest data from someone else's network who's already gone through that in selected areas. I see somebody smiling. Maybe not at this, maybe a joke that you told. But that is the easy way to go about it. And to be transparent, we do the same thing in Europe. We don't in the US. We have our own network in the US. But we're now deploying our own network across all of Europe. And why? If you have a deep interest in keeping your brand integrity, to have somebody who's providing you this data that's going to have that mower stay in the line it's supposed to stay, or the painter to paint what it's supposed to paint, right? If that's what you're developing, you don't want your brand given to a network that is completely up to someone else providing the infrastructure. They can't repair it. They can't. Monitoring is actually very difficult too, we know, because we do it and we try it. And so I highly encourage you, look for a platform that's wholly owned top to bottom so that any of the issues that pop up can be solved very, very quickly. So that's the network side of it. That was the first one. The second one is, don't try to read this too much, because I'm only going to focus on a piece of it. It's really the complete platform. And the important part of this I'm going to talk about is the positioning engine. So what I went through on the network is the correction side. If we look at the positioning engine, again, apologize if I'm preaching to most of you who already know this, right? That's the software that's taking the sensor signals and actually calculating the position. And it's really highly sophisticated software. So in an open sky environment, it's taking GNSS and RTK typically and calculating a position. When you get into a GNSS denied environment, well, that's no longer going to work. So what do? You rely on other sensors. So you'll have an IMU. You're just doing your relative positioning there. You'll have things like wheel ticks. You may even have video. And this positioning engine software is seamlessly shifting from, I have open sky, I don't have open sky, and now I have open sky again. And so your device now can track how it's supposed to track, regardless if it's going under a tree, it's going in a tunnel, or under a bridge. So that's the second piece, is providing that complete solution so that no matter where the device goes, it's going to stay where it's supposed to stay. And the last piece here is really the API side of this. And I think there was a few words on this earlier that I touched on. Those are familiar with, say, Stripe for payments or Twilio for messaging. Stripe didn't invent payments. Twilio didn't invent messaging. What did they do? They made it so damn easy for engineers and developers to use that service with just a handful of lines of code. And we think that location should be exactly the same. And so we have been developed API first from the beginning. Everything we build is through our own APIs. Our APIs are accessible for everybody else. You can provision your devices through an API. You can assign licenses at any stage of your own process through an application when the consumer opens that, or a dealer. You can configure devices, and you can configure individual devices to have different behaviors, like what's a data rate of that device that I want, if they're in a situation where the data rate actually matters and people are paying for it. The satellite signals that it ingests. So the ability to do this all through code and all dynamically, we believe, is a fundamental proposition that you need to provide these kinds of solutions. So just 3 quick examples to just kind of highlight the varied applications for this. So in the world of drones, and drones are used for lots of things from agriculture to inspection. In this case, this is about delivery, consumer delivery. The aspects of, obviously, delivering where you're supposed to deliver that package are very important. And GPS alone has too much variability. So very critical there, as well as the, believe it or not, there's a lot of GNSS denied environments that go on in drone delivery. They have actual docking stations where the drones come after they've done a delivery. Those things can cover the sky, and suddenly the drone doesn't know precisely where it is, and the efficiency of docking is greatly reduced, as an example. Second example here is really lawn, turf care, similar in agriculture. This example is a industrial lawnmower. And in many industrial lawnmower applications, especially if you look at golf courses, they don't want the lines in the golf courses or the baseball stadiums doing this. They need to be extremely precise. And just like in a drone world, there are many areas of a golf course that have occlusion and GNSS denied environments. And the last one is around more kind of 4-wheeled vehicles, if you will, that in this case it's the last mile segment for Amazon that uses a technology, of course, to shave seconds off deliveries. If they can just shave seconds off delivery by getting to the right door, instead of going to the front, the door's actually in the back, and they didn't know that. They can shave seconds by dynamically updating maps, where there's a closure on a road that hasn't shown up on Google Maps yet, and it was going to send them down a blocked road. They can update their own maps so that next delivery time, the delivery tracking software that's telling them where to go is going to ignore that street. So 3 key examples there. Hope that was helpful. Again, we're just down the street here, essentially, where the race car is. You can't miss it. If you have any questions, please come visit us. Thank you.